Hello, all you beautiful people. Welcome back to Living Environment. Here is President Obama. I asked him especially to make this gift for you guys because your work that you did last week was just so great. Just kidding. I don't know President Obama. I wish I did. That would be really cool. Okay. One thing that is true, though, is that your work was great. So your grades from Friday will be done at the latest by Wednesday evening, but probably by yesterday. So check them on Google Classroom or on Jump Rope. I'm going to post a video that's like, how do I check my grades? Because all y'all asking me, but I think you know how to do it. So I'm going to post a video about how to do that. In the meantime, if you are unhappy with your grade, if you got a 1 or a 2 and you want to reassess up to a 3, please come to revisions on Friday. This is your chance to improve that grade. If you have a 3 and you did not, and the reason you don't have a 4 is because you didn't use the podcast as one of your sources, then go ahead and just revise it and then send me an email that you included the podcast. All you need to do is like pick one of those questions and then go back through the podcast and find the evidence for it. Okay, so yeah, that's important. Anybody who you might have gotten a comment from Mr. Turbin or from myself that's saying like, this isn't a reliable source or this isn't a good source. If you can revise those on your own using one of the sources we gave you, that's fine. If you don't know like where you went wrong, please come to office hours on Friday. That's your chance to revise, okay? Awesome. If you just make edits to the document and you don't tell us that you're doing that, we're not going to go back and check it. So you got to make sure you come to those office hours because that's the only way I'm going to actually check it. All right? Okay, cool. All right. Where are we? We are on a new learning goal. Woo! All right. This is our 4th one. Or maybe our 3rd one. I think it's our 3rd one. Okay. We are going to interpret models to explain how antibodies and antigen receptor matching trigger the immune response. What? What are we, scientists? Yes, we are scientists. Immune response. That's a lot of vocab words. And you're going to learn them all. But in the meantime, what you need to know about this learning goal is we're going to basically learn how your immune system works, okay? So as we go forward today, we're going to get a little intro to that. We're going to learn what the immune system is and some really important components of the virus. And then the work that we do today and the work that we also do, it's going to kind of be a combo today and Friday in one document, is going to be assessed. Okay, so this is our first assessment for this learning goal is going to be on Friday. And then the next one will be 2 weeks from that. And this is going to be, we're going to really work with just like 2 resources over the next 3 weeks. One is an article from the New York Times, and then the other one is a comic that we're going to use to illustrate the immune system, and you guys are going to work on sort of building your own model that shows the same things. Okay, so here we are today. We're going to learn about how the coronavirus actually hijacks your cells. Crazy, right? Okay, let's do it. Let's get started. We're off to, on your marks, get set, go. Okay, so what are we going to do today? This video might be a little long, I'm sorry, but there's a lot of stuff to review before we get started. And then you're going to do a little bit of work around the scavenger hunt thing that I've sort of got planned. And that's it. That's what you're going to do today. Everything that we do today is going to come up again on Friday. So if you don't do it, it's going to be very hard for you to do Friday. So make sure you do it. Really focus in on this. Take the review. Though I am going to plug right now, if you're like, I don't want to sit through a long video, that's fine. Stop and come to live lessons. We'll do it all. It'll just be more fun. Okay? All right. Awesome. Okay, ready? Let's do a little whiteboarding virus review. This is all stuff from our day on Intro to Pathogens. The virus, or a virus, is an example of a pathogen. Yeah, I always think gen, germs. Pathogen, gen, germs. A virus is just one example. The other one is a bacteria. Okay, are viruses living or non-living? Non-living. Viruses are non-living. This is super, super important because they cannot reproduce by themselves. So the question is, how do they reproduce? We're going to find out. Okay. Which is bigger, a virus or a bacteria? A bacteria. Bacteria are so much bigger. So this big yellow guy is my bacteria and my virus is very small. Very, very, very small. Remember, bacteria is a whole cell. Bacteria are alive. Viruses are not. It's not a cell. It's like honestly too small to be a cell. All right? All right, let's talk about the parts of a virus. We talked about this a little bit the other day. We said viruses are very simple compared to bacteria, which are much, much more complex. So let's look at the most important parts. First of all, we have this area right here in the middle. It's got a bunch of stuff in it. What is that stuff called? Hey, that's my genetic material, aka DNA or RNA. Different types of viruses, some have DNA, some have RNA. DNA, RNA are made of nucleotides, right? So we're talking about A's, C's, T's, and G's if it's DNA, and A's, C's, G's, and U's if it's RNA, all right? Works the same way as our DNA, okay? How about this pink circle around the edge, kind of around the outside? So that's my protective envelope is sometimes what it's called. Sometimes people call it a protective layer. A lot of times people will call it a lipid layer, okay? It's fat. It's just a layer of fat. It protects the outside of the virus, okay? Or it protects the inside. It is the outside. It protects the inside. And then finally, we have these green things, which are super, 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 super important, okay? These are called my protein spikes, is one thing that you'll hear when we talk about them. And then the other word that you will hear is antigen, okay? And this is like bright red. It's very important. The antigen is a substance that indicates to the immune system that a foreign or toxic thing has entered the body. I want to name a couple of these, and then we'll look at that virus structure one more time. So when I talk about indicate, I mean like it's pointing it out or showing it, right? Maybe like if your bathroom door is closed, that indicates that someone is in there and you shouldn't go in. Okay, right? It shows it, points it out. If something is foreign, that means that it is not from your body. In this case, when we talk about the immune system, anything that's foreign is just something that's not from your body. Okay? When we talk about toxic, we mean poisonous. Okay? Like it's very bad for you. Not all foreign objects are toxic. Some are, some are not. For example, when you have allergies, it's because your body is reading something like dust as though it's toxic, even though it's not. It's just acting that way because it's foreign. It's not from your body. Okie dokie. Let me just move this and make sure everybody can read that, right? So an antigen is una proteína and un patogénico. So it's the part of the pathogen que le dice a su sistema inmunitario que es extraño o tóxica. So when we talk about that, I actually do want to go back to our protein here. This is the antigen. The whole thing is the foreign toxic substance. The antigen is the spike because it's actually what gives the warning that there's something there that's a problem. Okay? So that's what we mean when we say the protein on the pathogen. Okay, so the immune system, we've kind of been talking about this and you might have heard about this. Maybe your parents are like, eat your vegetables, it'll make your immune system stronger. This is all the parts of our body that work together to protect your body. These are all the parts that work together to protect your body. All right? And we're going to learn all about them. So, one last thing that I need to review before we go into the task that we're going to do, genetic expression. And this is going to be like a little bit of like a quiz for yourself. So genetic expression, let me give you the definition as like a little bit of a reminder. This is how a cell turns your DNA or your genetic code into a trait, como una célula convierte el DNA or código genético en un rasgo, right? I'm starting with my DNA and I am making a trait, okay? And when we talk about a trait, we always mean a protein, okay? So the first step, what would I fill in here? Right, transcription, okay? Transcription, this is when it happens. This is inside my nucleus. This is where I take my DNA and I turn it into RNA, right? DNA can never leave the nucleus. It is too important. It cannot leave the nucleus, okay? But it can make a copy of itself into RNA, and that will leave the nucleus. So that's called transcription. Once I have my RNA and I want to turn it into an amino acid chain, what is that process called? That's my translation. This is where I take my genetic code in groups of 3, right? AAG or AUU, and I turn it, I use my chart, my big chart, my codon chart, and I pick the right amino acid and I put them in a chain together. This is done outside of the nucleus. It's done by the ribosome. The ribosome does my translation. This happens in all of my cells. It takes the RNA and it builds the amino acid chain. And then finally, the last step here is protein folding. Okay, this is where I have my nice long chain. Fold it all up into a beautiful protein. All right, so this is connected to all of this stuff that we were talking about earlier with the virus. What would happen if a cell or the ribosomes in your cells read the genetic code from the virus instead of your own DNA? Instead of my messenger RNA going through that ribosome, what if instead it was reading the RNA from the virus? What do you think would happen? Okay, we're going to find out. So here's how we are going to find out. We are going to read this article. It's really amazing. It's really special. I really, really like it. Good news, if you would like to, you can read it in Spanish, right? That is your option. You can read it in Spanish. What are we going to do with it? So this article is very, very cool because it's got a ton of pictures. It's sort of like a comic. It's like a comic/news article. So as you read it, I want you to use the pictures to help you. Next, you are going to use this document here to tell you what you need to look for. So this is the sort of the scavenger hunt piece, okay? You're going to look for each of these images. The first one is a whole virus particle, and then you're going to look for the antigen or the spike protein. You're going to look for the lipid layer, a cell receptor, a viral RNA, a cellular ribosome, and the last thing you're going to look for is a newly created virus leaving the cell. You're going to look for those things and you're going to take a screenshot of them and put them in the table where it says image. And then use evidence from the article to explain the function of that structure. And then the last thing you'll do is answer this one question. So just to talk about some of the like how-tos around this, you're only going to use a partial screenshot. So if I took an image, if I just like screenshotted this whole article, it would have everything in it. I don't want that. I really just want the picture of the virus. So I'm going to use a partial screenshot, which is, it kind of depends on what your computer is. And if you're not sure, just Google it. But if you have a Mac, you're going to do the Command-Shift-4. If you have a Google Chromebook, you're going to use the Control-Shift and then the Windows page. key, the one that looks like this. And then your other option, if you have a Windows computer, you can use the snip tool, which is like embedded in just search in your applications for the snipping tool. You just want to take a picture of just the section that's important, okay? So as you put all of this stuff together, I just kind of want to look at the document together. This is a 2-day assignment. So on day 1, we're just doing the scavenger hunt. Day 2, we're going to have a whole other thing, kind of like a how-to. Both sections are going to be assessed, so please don't leave any of them out. Again, read the article, identify the key structures, so that's what you're going to take a picture of. Insert the image right into the table, and then go ahead and explain the function. Now listen, I understand if the language in the article is like the best language that you have, and that's okay. Now, if you choose to copy and paste from the article, and that is the only place that you are allowed to copy and paste from, only the article, put it in quotations, okay? That way I know that this is from the article, it's not your words. Does that make sense? That way we're like kind of giving credit to that. Okay? So structure, you're going to show the image and then tell me what the function is. Use the evidence from the article. The article is really, really good. And then answer this last question. How do the structures in a virus help it reproduce? All right, y'all? All right. Have a great time. And guys, really come to live lessons. Live lessons are fun. Also will help you. Like, why struggle through it? Just come and get help. All right? Love you. Miss you as always. And talk to you soon.